Hello everyone, we're diving into using the quadratic formula to solve quadratic equations. If you don't have your notes turned to this part, go ahead and turn there. You can pause the video and make it happen. But yeah, we're diving into the quadratic formula, which is this thing. So the quadratic formula is a formula where you put in numbers. That's usually how formulas work. But what it does is it solves your quadratic equation for you. These B's and A's and C come from the standard form of a quadratic. And the A, B, and C are there only if it equals 0. So you need to make sure before you plug numbers into the formula that your equation equals 0. If it doesn't equal 0, make it by subtracting everything over to the left or right side, whatever side has your quadratic. And the B's are the terms that are on the x. The A's are the term that's on the x squared, are the coefficients on x squared, and then C is the constant term. And what you're going to do is you're going to plug the numbers in and simplify, and it gives you your answers. And the convenient thing about the quadratic formula is it works for every quadratic. It's very convenient. So you remember all that factoring stuff we did and all that completing the square stuff we did? Yeah, it does all that. Just makes it happen. And something real quick to help you remember is you can say this to the tune of Pop Goes the Weasel, if you know that song, little children's song. It goes like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there you go. That's how you can remember your quadratic formula. Let's try it again. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And there you go. You can remember your quadratic formula for forever. Sing it to yourself a couple times so you got it down. But let's go ahead and see how it works out. Let's say we had an equation here which it should be equaling 0. It should be equaling 0. And this term here is the a term. This coefficient here is the b coefficient, and this here is c. So a is 2, b is negative 3, and c is negative 3. And you put those numbers in the quadratic formula in these spots, where the a's and c's and b's are, and then you simplify. I want to point out that the very first thing is negative b, and if b is already negative, it becomes negative, which turns it into a positive when you get to your next step there. So please don't mess up on the very beginning part. Negative b. Whatever b is, you put a negative in front of that, and it's going to change its sign. And then you got your plus or minus. And then inside here, you're going to have to put b squared. It doesn't have it here, but you definitely want to make sure you put parentheses around all the numbers that you plug in. Because if you don't, you're probably going to mess up some signs somewhere. You just got to be really careful. This is going to be b squared, so negative 3 squared. And then minus 4a is 2. C is negative 4. So I like how they put it in parentheses here. And it's all over 2 times a, and a is 2. Again, make sure you put parentheses. And so the next step here is just simplifying that down. Sorry. The 3 became positive because it was negative of negative 3. Negative 3 squared became 9. And then minus 4 times 2 times negative 4. 4 times 2 is 8, times negative 4 is negative 32, but you're subtracting it. So it's subtract negative 32, which turns into plus 32. And then the inside part, 9 plus 32, comes out to be 41. And 41 does not factor. You can't simplify that part. No, it's not more. It's not a perfect square. And so it just turns into 3 plus root 41 over 4. And 3 minus root 41 over 4. And those are the two answers. Those are the two spots where this quadratic is equal to 0. So here's our quadratic formula. It's awfully convenient. It solves things for you. So let's jump down here And let's have you give it a shot. Pause the video, see if you can solve this using the quadratic formula. All right, how'd it go? Did you do x equals -5 plus or minus the square root of 5 squared minus 4 times 10 times -1 all over 2 times 10? That's how you should have plugged it in, because this is your A values, 10. B is 5, and C, remember, take signs with it, so C is going to be -1. And the rest of this is going to be simplifying. So you got -5 plus or minus. And I tend to just put this entire chunk in the calculator all at once. And yes, you can use a calculator. It's great. You should do that. So I'm going to do 5 squared minus 4 times 10 times -1. Plug that, and I get 65. And it's all over 20. And yes, don't put the square root yet. Just put what's inside the square root in your calculator. That way you can write it here. Because this is going to be the exact answer here. And that'll be, kind of what you need. 65 doesn't really simplify because it's 5 times 13. And those are prime, so you can't take that down anymore. And so this is actually the answer. It's both answers because it's got the plus and the minus. I'm okay if you just write it as one statement. But if you want to write out -5 plus root 65 over 20 and -5 minus root 65 over 20, that's fine too. Let's jump over to the next one. Again, pause the video, see if you can solve this quadratic equation using the quadratic formula. All right, first things first. Did you remember that it needs to equal 0? If you miss that part, it kind of messes up the whole rest of the process. So you need to add 2 over, so it equals 0. So now we got 2v squared minus 11v minus 40. And then you can plug in your variables. In this case, it's going to be v equals negative of -11. I said 11. Plus or minus the square root of -11 squared minus 4 times 2 times -40 all over 2a, and a is 2. So that's all of it plugged in. Again, you're just going to go, the next step is simplifying. Negative of -11 is positive 11. Plus or minus the square root of something. I'll get there in a second. 2 times 2 is 4, so that goes on bottom. So now you plug this in. -11 squared, and make sure when you put it in the calculator, again, it has parentheses, minus 4 times 2 times -40 equals, you get 441. I wonder if that is a perfect square. It might be. Oh, it is. Perfect. Awesome. So the square root of 441 is an actual integer. And so I'm going to compute that. So v is going to be 11 plus or minus 21 over 4. Make sure you always check it to see if you can square root it. If you can, do that. And this does make 2 different answers. You get 11 plus 21 over 4, or 11 minus 21 over 4. And then you can simplify both of those. Let's see, 11 plus 21 divided by 4 gives you 8. And the other one, 11 minus 21 divided by 4. That one gives you a little fraction there, which is fine. So it's -5 halves, or -2.5. But yeah, we'll write it as a fraction. Ta-da! So you solved it now. If you got those 2 answers, good job. If you didn't, kind of look through and see where things might have gone wrong for you. Well, there you go. Let's jump to our third example here. In case you forgot last time, this time remember, it needs to equal 0, not something else. So go ahead and move that over and then finish solving. All right, let's go ahead and check and see how things went. make sure you add the 4n over. We'll start figuring out what n is. So you got negative b in this case is 4, plus or minus the square root of b squared, 4 squared, minus 4 times a, which is 9, and c, which is 7, all over 2a, and a is 9. So my next step is to simplify all that down. We got negative 4 plus or minus the square root of something over 18. Now I'm going to plug in the something, the inside part there, into my calculator. I got 4 squared minus 4 times 9 times 7. And that gives me negative 236. All right. So we finally reached the point where we have a square root of a negative. We might have talked about this previously, but I can give a reminder here. If you have the square root of a negative, it doesn't really pan out. Like, if you want to try, you can put it in the calculator, like do square root of negative 236. And you can kind of see what happens. Your calculator should give you an error, say like error, non-real answer, or something along those lines. And that's because this is non-real. And in math, real is a specific kind of number. There's no real number that you guys would be familiar with, that when you times it by itself, you get a negative. And so what we have to do is actually rewrite this using imaginary number notation. So I'm going to do negative 4 plus or minus. And the way you convert this to imaginary terms is you're going to put an I. I do kind of a backwards J because that's just a kind of formatting thing to let me know it's I, kind of special I in the imaginary number. And then you can put the positive version of what was under your square root. And so you can do I square root of 236. And I think that is not a nice, that one's not a nice square root. It's not a perfect square. So we're going to leave it like that. Yeah, and for this assignment, we're not going to worry about simplifying these things. Like, I know you can factor it, like, that's divisible by 4 and stuff. But for today, we're just focusing on getting to this point. And we're going to have that be our answer for now. So yeah, if you have a square root of a negative, you need to put I out front and then change this to be a square root of a positive. The I lets you know that this has an imaginary answer. And we are later on in a future unit learning about what imaginary means and things like that. So there you go. There's our lesson on solving using the quadratic formula. If you want to see some other examples, there are these 3 other examples here. This one also shows you that how you can end up with an I at the end. This one also ends up with an I at the end. But if you have, the square root of 4, which is a nice number, it turns into 2i, because the square root of 4 is 2. And at this point, you can split it up into your 2 different things, but yeah, it doesn't happen super often. But there you go.